How many people completed assignment? Just raise your hand. Assignment, how many people completed? 1, 2, 3, 4, 5, 6, 7, 8, 9. Online students? Okay. See. Assignment, 11 programs are there. 11 programs. See, without class, we cannot develop applications. So class name, open brace, close brace. Okay. After that, main method. Public, static, void, main, string, aux. Now, first program, write a program to display factors of a given number. Okay. Suppose if it is number is 6, 6 factors are 1, 2, 3, 6. Okay. Factor means given, say 1 to given number. Given number, suppose 6. 1 to given number, 1 to 6. Each and every number you have to check whether it is factor or not. Okay. Reminder 0, if it is comes, it is a factor. First of all, you have to accept one number. For accepting one number, already some code I explained with scanner class. So scanner is equal to new scanner system.in. This line I didn't explain. I'll explain later. This line not I didn't explain till. It is not possible to explain also now. Okay. For learning this one, object-oriented principles required. Now scanner class available in util package. It is compulsory. We have to import java.util.star. Now system.out.print, enter any number. Okay. Enter any number. Enter any number. Now I given integer x equal to s dot next int. Now you will get a one number. Okay. This is a code till I didn't explain about this. Further I'll explain. See, scanner class object created. With that scanner class object, next int method, if you call, you will get an integer. Whatever you enter stored in x. Now, if you want to display this number, directly you can display system.out.println x. Okay. This program you observe. First, scanner class object created. But scanner class object, I passed system.in as a parameter. This is today not possible to understand. Further, I'll explain about this line. Okay. Enter any number displayed on monitor. I used print method. Print method means after printing cursor will be in the same line. Print ln method means after printing cursor comes to next line. That's the difference. Now, whatever you enter, it is stored in x. That x is going to be printed. File, save. I'll compile, I'll execute. You observe. See, Java C demo.java compilation Java demo. See, enter any number. It is displayed on monitor. Say print method I used. That's what cursor is here. Print ln method if I use, cursor comes to next line. Okay. Now, whatever I entered, that number received by x. That number printed. It is input, it is output. Now enter any number, whatever you enter, that is displayed. Now we don't want this one here. Whatever you enter, that number of factors we have to display. Okay. Suppose this x value, if it is 6, 1 to 6 required. If the x value 20, 1 to 20 required. If the x value 40, 1 to 40 required. If the x value 99, 1 to 99 required. That means 1 to this x, we have to write loop. What we have to write? For loop, int I equal to 1, I less than or equal to x, I plus plus. This is one loop. This is one loop. So if the x value 6, 1 to 6. If the x value 10, 1 to 10. The x value 40, 1 to 40. Now each number, whether it is factor or not, you have to check. If it is remainder 0, then it is a factor. For getting remainder, which operator? Modulo division operator. So one condition, if x modulo division I, if it is 0, then system dot out dot println I. Over. Now here 1, first I value 1. 1 modulo division 1 less than or equal to 6. Suppose x value 6. 1 less than or equal to 6. True. 6 modulo division 1. 0. 0 double equal to 0. True. Then 1 printed. Later I becomes 2. 2 less than or equal to 6. True. 6 modulo division 2. 0. 0 double equal to 0. True. Then 2 printed. It will become 3. 3 less than or equal to 6. True. 6 modulo division 3. 0. 0 double equal to 0. True. Then 3 printed. It will become 4. 4 less than or equal to 6. True. 6 modulo division 4. You will get a remainder 2. 2 double equal to 0. It won't print. Then directly 5. 5 less than or equal to 6. True. 6 modulo division 5. 1. 1 double equal to 0. It won't print. Directly 6. 6 less than or equal to 6. True. 6 modulo division 6. 0. 0 double equal to 0. True. Then printed. Later 7. 7 less than or equal to 6. False. Stop it. Now see. File. Save. Compilation. Execution. See, enter any number. 6. 6 factors are 1, 2, 3, 6. See. 1, 2, 3, 6. Suppose Java demo. Again I'll execute. Enter any number 10. 10 factors are 1, 2, 5, 10. Okay. See 1, 2, 5, 10. Now Java demo. Suppose 25, 26. 26 factors. 1, 2. Next 13. Next like that. 1, 2, 13, 26. Any number that factors printed. Okay. Not visible. Okay, 1 minute. Now any number you enter. Any number you enter. See Java demo. Java demo. Suppose 55. See 1, 5, 11, 55. So remainder is 0. That is a factor. If it is that is factor displaying. Now write this one. Program to display factors of a given number. 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 Your answer can be right or wrong. You have to try. Today night I'll share one more assignment. Again 1 week time. You have to try to complete. Okay. With while loop also, for loop also, do while loop also possible. Any loop. See, if the value of x, suppose 6, suppose s dot next int, whatever you enter, that is stored in x. That value, suppose x, that value 6. Then I value 1. I value 1. 1 less than or equal to 6. 1 less than or equal to 6. It is true. It is true. Say I value 1. 1 less than or equal to 6. True. It will enter. Then 6 modulo division I. X modulo division I. 6 modulo division 1. So 1 6 6. 1 6 6. Remainder 0. Remainder 0. Okay. So here 6 modulo division 1 double equal to 0. It is true. It is true. Then printed. Output 1 printed. 6 modulo division 1 double equal to 0. Output that 1 printed. Now after printing 1, I becomes 2. I becomes 2. 2 less than or equal to 6. 2 less than or equal to 6. It is true. Okay. Next, 6 modulo division 2. 6 modulo division 2. 2 3 6. 2 3 6. Okay. Remainder 0. Remainder 0. Here also remainder 0. Here 6 modulo division 2 double equal to 0. If it is true, it is printed 2. After this, see, after this, control comes here, no? I plus plus. I becomes 3. I becomes 3. 3 less than or equal to 6. It is true. Then 6 modulo division 3. 3 2 6. 3 2 6. Remainder 0. Then 6 modulo division 3 double equal to 0. True. Output is 3. Okay. Now next I value 4. 4. 4 less than or equal to 6. 4 less than or equal to 6. It is true. Then 6 modulo division 4. 4 1 ja 4. Remainder 2. 4 1 ja 4, remainder 2. So 6 modulo division 4 double equal to 0. It is false. That's what it will not print. Then it will become 5. 5 less than or equal to 6. It is true. Okay. Then 5 6 5 1 ja 5. Remainder 1. Remainder 1. So 6 modulo division 5 double equal to 0. It is false. It will not print. Then it will become 6. 6 less than or equal to 6. It is true. Then 6 modulo division 6. 6 1 ja 6. Remainder 0. Remainder 0. Then 6 modulo division 6. Double equal to 0. It is true. Then 6 printed. After this, it will become 7. 7 less than or equal to 6. It is false. It is stopped. So here condition false, it will come out. Okay. This is execution process. So first scanner class object created. Enter any number displayed on monitor. Whatever you enter stored in X, that X value, suppose 6. Then for loop started 1. 1 less than or equal to 6. True. It will enter 6 modulo division 1 double equal to 0. True. Then printed. This is continued 6 times. After that, 7 less than or equal to 6. False. This is a program. So what you have to do is, whatever a given task, you have to try to complete with your own logic. After that, wrong output comes. Then you trace like this. If you trace like this, where is a mistake, you will understand. Where is a mistake happened, you will understand. Already you know for loop how it is executed. If condition how it is executed. The execution order you know. Based on that, you trace where is a mistake happened, you will understand. Okay. Like that, you can improve your logical skills. So already you know for loop, first this is executed. Next this is executed. True means it will enter. False means out of. Again this is executed. True means it is printed. False means out of. Again after this I++ executed. Again this one. That execution order already you know. Like that, one by one you trace. If any wrong output is there, where is a mistake happened, you will understand. With that, again you can make it correct. Okay. So any task if I give, you try to implement yourself. If you get a wrong output, you trace like this. You'll get a result. Got it? Now, this is a program to display factors of a given number. Now, this is first program. Say you enter any number that factors displayed. Say I entered 55, 1 to 55, each and every number checked, 1 to 55. That loop iterated 55 times. That condition checked 55 times. Okay. Now condition 4 times only true. That's what 4 values came. Now second program little bit different. What I given? Write a program to calculate the sum of the factors of a given number. Okay. Just here factors printed. But what I asked second program to display sum of the factors. Just you need to add. Okay. Just you need to add some of the factors. So just in the place of printing one sum variable you can take. Suppose integer sum equal to 0. Then add to sum. Now sum equal to sum plus I over. Now, if it is factor, that value added to sum. After completion of for loop, display sum. System dot out dot println sum. Now, suppose now you observe. Suppose 6 is a number. Now 6 is a number. You accepted. What are the factors? 1 plus 2 plus 3 plus 6. Result what it comes? 12. There is output. If it is factor, it will be added to sum. If it is factor, first sum value 0. Now 1 is a factor. 0 plus 1, 1. Like this, 1 it becomes. Next, 1 plus 2, 3. 3 plus 3, 6. 4 is not a factor, not added. 5 is not a factor, not added. 6 is a factor, 12. So 6 plus 6, 12. See, compilation, execution. Suppose 6, output is enter. They're entered. Okay. 6. See, output is 12. So Java demo. Say, suppose 10. 10 factors are 1, 2, 5, 10. 1 plus 2, 3. 3 plus 5, 8 plus 10, 18. Like this. So, program to display some of the factors. Now, program to display some of the factors of a given number. Write this one. Program to display some of the factors of a given number. Write the program. Program to display some of the factors of a given number. If it is factor, we are adding to sum. That's it. If it is factor, we are adding to sum. These all to improve your logical skills. Okay. After getting a job, these are not required. For getting a job required. Okay. For getting a job required. After getting a job, library we use. We use library. After getting a job, calculating factorial, square root, Armstrong number, strong number, these are not required. After getting a job. Before getting a job required. For getting a job required. Program to display some of the factors of a given number. See, initially x value 6, sum value 0. Initially x value 6, sum value 0. Here I value 1. 1 less than or equal to 6. It is true. Then it will check 6 modulo division. 6 modulo division 1 double equal to 0. It is true. Then sum equal to sum plus I. 0 plus 1. It will become 1. Next, I becomes 2. 2 less than or equal to 6. 2 less than or equal to 6. Okay. 6 modulo division 2 double equal to 0. It is true. Then again sum equal to sum plus I. Sum value 1, I value 2. 1 plus 2, 3. Then I becomes 3. 3 less than or equal to 6. It is true. Then 6 modulo division 3. 6 modulo division 3 double equal to 0. It is also true. Then sum equal to sum plus I. 3 plus 3, 6. Next, I becomes 4. 4 less than or equal to 6. It is true. But 6 4 modulo division 4. It is false. It is false. Then 4 will not be added to sum. If this condition is true, then only added to sum. This condition false, not added. Then I becomes 5. 5 less than or equal to 6. It is true. But 6 modulo division 5 double equal to 0, false. If it is false, it is not added to sum. Now it will become 6. 6 less than or equal to 6. It is true. 6 modulo division 6 double equal to 0. It is true. Then this 6 added to sum. 6 plus 6, 12. Next it will become 7. 7 less than or equal to 6. False. It is stopped. Now, if it is this is false, it is stopped. Stopped out of for loop. System dot out dot println sum. What is the output? 12. Okay. This is tracing. Like this, one element, how it is working, what is happening, you trace. If any wrong output is there, trace. Then you will understand what is the mistake happened, where is the mistake happened. Okay. Like that, you can write. If any task, if I give, first you try to implement yourself. If you get a wrong output, you trace like this. Then what is the mistake, where is the mistake, you will understand. Again, make it correct. Then you'll get it right output. Okay. This is about tracing. This is some of the factors. This second program. Okay. Say first program to second program, little bit different. No? First program to second program difference is only adding to sum. One variable, adding to another variable. First program printing. Second program adding to another variable. That's it. Second program to third program also little different only. What I given? Write a program to display to check whether given number is perfect number or not. Perfect number nothing but sum of the factors. If it is equal to given number, that is perfect number. So now suppose 6. 6 factors are 1, 2, 3, 6. Except this number. Except that number. That means here less than or equal to x have taken, less than x. Okay. That means less than one number less than you have to take. except a given number. Now, if you add these three, 1 plus 2 plus 3, what is the result? 6. If it is equal, it is perfect number. So second program to third program, only one if condition you have to write. That's it. Okay. So here, less than or equal to x is just you have to remove equal to, less than, one number less than. After that, you'll get a sum. If sum double equal to a x, whatever taken x, then given number is perfect number. Given number is perfect number. Else, given number is not a perfect number. So given number is perfect number. If it is total, if it is equal to given number, then given number is perfect number. Otherwise, given number is not a perfect number. See, program to check whether given number is perfect number or not. See, program to check whether given number is perfect number or not. Now, file, save. I'll compile. Compilation, execution. Now, I'll enter 6. 6 factors. 1, 2, 3, 6. Except 6. 1, 2, 3. 1 plus 2, 3. 3 plus 3, 6. So, given number is perfect number. Suppose Java demo 10. Java demo, enter any number 10. 10 factors. 1, 2, 5, 10. Except 10. 1 plus 2, 3. 3 plus 5. It is not a perfect number. Given number is not a perfect number. Suppose Java demo 14. 14 factors. 1, 2, 7, 14. Except 14. 1 plus 2, 3. 3 plus 7, 10. So given number is not a perfect number. Suppose 28. 28 factors. 1, 2, 4, 7, 14. Now 1 plus 2, 3. 3 plus 7, 3 plus 4, 7. 7 plus 7, 14 plus 14. It is a perfect number. Given number is perfect number. So first program to second program little different. First program displaying factors. Second program adding to sum. Third program given number that is equal or not. That's it. Like this only you can improve your skills. That's what same order I given. Okay. Write this one. Program to check whether given number is perfect number or not. Write this one. Those who completed, no need to write. Those who completed, those who got all right output, no need to write. Program to check whether given number is perfect number or not. Next to fourth program also same, little bit different again. In an order I given, in a proper order. So almost 11 programs, 8 programs, same style. 8 programs, same style I given. Online students, end of the session, I'll clarify your doubts. Program to check whether given number is perfect number or not. Online students, end of the session, I'll clarify your doubts. So here, if it is factor, we are adding to sum. After completion, sum and given number, if it is equal, then given number is perfect number. Otherwise, not a perfect number. First program I displayed factors. Second program added to sum. Third program, sum and given number same or not, we checked. If it is same, perfect number. Not same, not a perfect number. That's it. Okay. Is it over? Fourth program, write a program to display perfect numbers from 1 to 1000. That means 1 to 1000, one loop you have to take. Each number, whether it is perfect or not, you have to check. If it is perfect, you have to display. Just x place, x value 1 to 1000 required. That's it. Now only one number x I have taken. That x is perfect or not, I checked, I printed. Now what you have to do? X place 1 to 1000 you have to take. Now the same logic inside the loop. And instead of like this, print that number. See here. Now here you observe this scanner class not required now. Now here x place for integer x equal to 1, x less than or equal to 1000, x plus plus. Now x value 1 onwards it will take. If it is sum, if it is equal, then print the x value. Over. Same logic. Now x value 1 comes. 1 is perfect or not, it will check. If it is perfect, printed. Now 2 comes. 2 is perfect or not, it will check. If it is perfect, printed. Like this, 1 to 1000. Same logic applied. See, file, save. This logic I written in a loop, one loop. That's it. See, compilation, execution. There are only 3 perfect numbers are there. 6, 28, 496. 6, 28, 496. Okay. Now, this is a program to display all perfect numbers from 1 to 1000. Program to display all perfect numbers from 1 to 1000. Online students, end of the session, I'll clarify your doubts. Listen the class, write the notes. End of the session, I'll clarify your doubts. Program to display all perfect numbers from 1 to 1000. Program to display all perfect numbers from 1 to 1000. I didn't get you. Variable. It some variable. No, because it has to start with 0. Like declaration outside. Later sum equal to 0 inside. It works. Over. Now, program to display all perfect numbers from 1 to 1000. Next to program also little bit different. What I given is write a program to display all perfect numbers in a given range. It is 1 to 1000 I given, but later instead of 1 and 1000 you can take whatever you want. Starting number, ending number you accept from keyboard, and starting number year 1, ending number 1000. Instead of 1 to 1000, whatever you want you can accept dynamically. That is starting, ending only you have to accept, you have to write. See, is it over? This is 1 to 1000. Now what you do is here before this only you accept one number. Scanner class. Scanner is equal to new scanner. System dot in. System dot out dot print. Enter starting number. One number you accept. Integer x equal to s dot next int. Again system dot out dot print. Enter ending number. Where you want to end. Integer y. S dot next int. Now here this year you have tried x. Okay, here already x are written. Okay, something. It is a. Otherwise start. Variable name start. Year variable name end. Now x equal to 1 place start. Now year less than or equal to 1000 place end. Start to end. Whatever you want you can take. Program to display all perfect numbers in a given range. Range I am specifying. You observe compilation, execution. Suppose enter starting number. Suppose I want 5,000. Enter ending number. I want 10,000. Now the 5,000 to 10,000 perfect numbers displayed. There is only one perfect number, 8,128. Okay. Now, whether it is right or wrong, if you want to see, I didn't change any logic also. Suppose Java demo. Suppose 1 to 100. 1 to 100, 6 and 28. Okay. I didn't change logic, only added. Okay. So, like this, program to display all perfect numbers in a given range. Whatever you want, you can write. That's it. Write this program. So fourth program to fifth program, just two variables I accepted. Start, end. So 5 programs, same style. Remaining next 3 also same. Prime numbers. That is also factors related only. Program to display all perfect numbers in a given range. Online students listen the class, write the notes. If I click chat box, the chat box visible to offline student, they cannot write the notes. End of the session, I'll clarify your doubts. If any doubts are there, end of the session, you can ask. If I click on chat box, they cannot write program. Online student chat box not visible, but offline student chat box visible. Then how can they write program, this program? Program to display all perfect numbers in a given range. Over. So given range, starting, ending. So start to end. Each and every number checked. If it is perfect, printed. Five programs completed. Sixth program, prime number. Prime number means 1 and given number. That is only factors. Those only factors, no other factors. Suppose 7. 7 factors. 1, 7. No other factors. 9. 1, 3, 9. It is not a prime. It is a prime. Now, this logic, two different types we can write. What you can do is, you can count the number of factors. If only 2 factors are there, prime number. That is one logic. One more logic, start with 2, end with given number minus 1. In between factor is there. Break the loop. Display it is not a prime number. Two logics possible. One is count the number of factors. Say, suppose 7 is prime or not? Yes. Now, how many factors are there? 2. Here, only 2 factors are there. So, it is a prime. Like this you can write. One more what you can do. Now, if you write like this, what will happen? First, it will check 1 is factor or not. 2 is factor or not. 3 is factor or not. 4 is factor or not. 5 is factor or not. Like that, 1 to 7. How many times loop is iterated? 7 times. After iterating, it will count 2 factors are there. So then it will display it is a prime number. This is one logic. One more logic, you start with 2. Start with 2 loop and end with 6. In between factor is there. Terminate. Suppose now 2 to 6 iterate. In between factor is there? No. So it is there is no factor. So it is prime number. Now what is the benefit you observe? Suppose 9 is there. 9, 1, 3, 9. Now 3 factors are there. 3 factors. Is it prime? No, it is not a prime. This logic you can write one more way. What you have to do? 2 to 8. 2 to 8 you can take. 2 to 8. Now when 3 comes, 3 is a factor. Then you can break the loop. Then how many times iterated? Only 2 times. 2 comes, 3 comes, break. Then it will display it is not a prime. But if you write this logic, 9 times iterated. After 9 times only, it will understand it is not a prime. That's what. Which is better? Second logic is better. Okay. Now both the logic works, but performance point of view. Suppose 999 one number. 999. Is it prime? Is it prime? No. Suppose what we will do? 1 like next 3 like this up to 999 you will check. Okay. Total how many primes are there? It will count. Then more than 2 is there. More than 2 is there. Then it will display not a prime. Okay. Not equal to 2. Then not a prime. But how many times loop iterated? 999 times iterated. With the second logic, 2 to 998. Now 2 is not a factor. 3 is a factor. You break the loop. Display not a prime number. In how many iterations completed? Only 2 iterations. It is better, no? That is 990 times 999 times iterated. This is only 2 times iterated. It will break. It will come out. It will display not a prime. What do you want? So 2 logics possible for prime number. See. Now first accepting one number. This is normal. Okay. Now here enter any number. Now enter any number. Whatever you enter, it is stored in X. Okay, it is stored in X. Now first logic. 1 to given number. You write loop. What you write? Int I equal to 1, I less than or equal to X, I plus plus. If X percentile I double equal to 0, then you have to count one count variable. Int count equal to 0. Then increase the count. Count plus plus. Again, right now, count will increase. After terminating for loop, if count equal to 2, system.out.println, given number is prime number. Else, given number is not a prime number. You can write now. Say, suppose X value 6. X value 6. Count equal to 0. Here 1. 1 is remainder 0. X sub 6 modulo division 1. Remainder 0. Count will become 1. 2 is also factor. Count will become 2. 3 also factor. Count will become 3. 4 is not a factor. 5 is not a factor. 6 is a factor. Count will become 4. Count 4. 4 double equal to 2. False. Then given number is not a prime number. File save. Compilation. Execution. Suppose 6. 6 factors are 1, 2, 3, 6. How many are there? 4. 4 double equal to 2. False. Given number is not a prime number. Java demo. Suppose 7. 7 factors are 1, 7. How many factors are there? 2. Count value 2. 2 double equal to 2. True. Then 1 minute. Some mistake happened. Where? Here semicolon I given. That semicolon empty statement. Compilation, execution. See, 6. 6. 4 factors are there. Count value 4. 4 double equal to 2. False. Given number is not a prime number. 7. Given number is prime number. Java demo. 9. 9 factors. 1, 3, 9. How many factors are there? 3. Count value 3. 3 double equal to 2. False. Given number is not a prime number. Suppose 11. 11 factors. 1, 11. Count value 2. 2 double equal to 2. True. Given number is prime number. Okay. Write this one. Program to display. Program to check